All right, guys, we're going to talk through just the last half of the Module 6 homework, or the last couple pages, I guess. So let's start. So problem number 7 says, given that A represents the input value and B represents the output value, write the formula of the line that has a constant rate of change of 3 and a reference point of -2.8. So this is really the same thing that we've been doing, so that should be pretty straightforward. I'm just going to write +2, right? It's minus and -2, like so. Part B says write the formula of the line that has a constant rate of change of 0 and goes through the point for -2. So I could start off by writing the same way I just did on A, but then 0 times any number is just 0. So essentially this is going to just simplify. So B equals -2. Really, this graph is a horizontal line, right, at an output of -2. So this is really just a horizontal line. So we're saying that the output is always equal to -2. For part C, it says write the formula of the line that has a constant rate of change that is undefined. By the way, that's going to be a vertical line, and goes to the point 5, -3. Probably it's actually easiest to do the graph first in this case. So I'm going to go and plot that point. And if we know it's a vertical line, the graph is going to be like this. So it's not the output that's the same, it's the input. So in this case, I'm going to say the input, and the input's always going to be equal to 5, right? And essentially we're getting that from here. So no matter what the output is, the input is going to be 5, which again is why it's a vertical line and an undefined constant rate of change. And consequently, by the way, not a function. All right, question 8 says use the graph and the function below to complete the following. So A says to match the formulas for each function to the correct graph. You have a couple ways of doing this. You could look at the reference points, or you could look at the constant rate of change. If I looked at the constant rates of change, essentially what I'm looking at is, so I notice that these two are positive, and so those have to be one of these two graphs. The larger the rate, the steeper my graph is, and so essentially this I know has to be F, and this has to be M. I can do something similar with the last two, right? Those rates are negative, so my graphs are decreasing. So I have -1.5 and -3. Well, -3 is decreasing faster compared to the -1.5, and so I could label my graphs like that. Part B says to determine the vertical intercept of each of the functions and plot on the thing, or plot on the thing, on the graph. Honestly, the easiest way to find these is just to look at the graph because I made the points really easy. And so I'm going to do that. So F is red, and so here my vertical intercept I can see is 0, 1. For M, that's my blue one. So it's down here at 0, -3. Notice my vertical intercept always has an input of 0. For P, I'm actually up here at 0, +3. And then B is my purple graph, so I'm right here at 0, 2. I could also find this with my formula if I input 0 for A, but that's just going to take more time, and I like to be efficient. For part C, it says to list the functions by their function name or letter according to the value of their constant rate of change in order from least to greatest. And so what that essentially means is I have a number line and I want to list from least to greatest. So the smallest my rate of change is -3, then -1.5, then +2.5, and then 4. So I just need to write those. So B, P, M, and then F. D says to list the functions according to their steepness in order from least to greatest. Now, steepness ignores the sign of the constant rate of change, whether it's positive or negative, and it just looks like at the size or the magnitude. So essentially, we're ignoring whether it's positive or negative, and we're just ordering from least to greatest in terms of the magnitude. So when I do that, it's going to change my order, and we're going to look like this. All right, so that's the difference. In steepness, we ignore the sign. All right, so for question number 9, it says determine the formulas for each linear function given on the graphs. Hint, identify 2 points and find the croc. We're going to let x be input and w be output. I'm always going to pick 2 points that I can easily see. So let's go with this one, and I'm going to go with this one here. I'm going to make a table, so x and w. So this is 4 and 0, this is 6, and this is -3, by the way. So this is a change in input of 2, change in output of -3. So my proc, change in output over change in input, I'm going to get -1.5. And so then I'm just going to pick one of my reference points. If I pick the first one, I guess I'll do this. No, try that again. -4 plus 0. And so I'm just going to leave it like that. I'm going to do the same thing on the second one. I'm going to use this as a reference point. I guess I'll just use my intercepts. I'll make my table here. So x and w. So 0, -4, and 2, 0. So 2. This is 4, so my croc is just going to be 4 over 2, which is 2. I'm going to use my simplified form because I've got it. Right, I have my vertical intercept, so it's going to be 2x minus 4. You don't have to, but why not? All right, and then finally it says you own a very popular local clothing boutique whose profit has been increasing at a constant rate of change each year since 2009. The input, oops, sorry guys. Sorry about that. The input of the situation is the number of years since 2009 T, and the output is the profit in thousands of dollars, so we have to be careful. In 2011, so I'm just gonna, I guess, make a table now. I don't know if it asked me to or not. So in 2011, so it's 2 years after 2009, you made a profit of $23,000. And in 2014, which is 5 years after 2009, you made a profit of 30.2. A says rewrite the information as coordinate points or organize in a table. Yay, I did it. And use these to find the constant rate of change. I should have done it somewhere else though. So my change in input is going to be 3, so 5 minus 2. My change in output, 30.2 minus 23, is going to be 7.2. And so my croc is going to be 7.2 over 3, and I'm going to get 2.4, and that is $1,000 per year that my profit's increasing. So I guess I just need to put that in words. So every year, the boutique, can I spell boutique? Makes an additional $2.4 thousand. You could write it as like $2,400 if you want, in profit. All right, and then finally, part C says write a linear function that describes the relationship between the profit and thousands of dollars with respect to time since 2009. So we have our croc. Pick one of those 2 points as your reference point. I guess I'll pick the first one. And we are done. Go us.